this database got it 100% correct. This is insane. I actually had to double check my code to make sure it's not a bug. I built a semantic music search engine using 5 different vector databases to answer the ultimate question. Which one is the absolute best vector database out there? Stick around to find that out. The results might surprise you. So in this video, you'll learn what vector databases are, how they work, how to benchmark them head to head, and how to use them to build your own semantic search engine from scratch. It's going to be a lot of fun, so let's dive into it. So first of all, what is a vector database? At its core, it's a specialized database designed to store data in vector format. It searches through high-dimensional vectors, which are basically numerical fingerprints of data like text, images, or audio. You can think of it like plotting every piece of data as a point in a giant multi-dimensional space. When you search for something, the database doesn't look for exact matches like a normal SQL query. Instead, it finds the nearest points, or in other words, the closest neighbors in that space. That's how it can tell you which songs or documents or images are most similar to what you just asked for. And that matters a lot because LLMs rely on that kind of similarity search to craft their answers, pull context, and retrieve the right knowledge in real time. So for our project, we'll be building a semantic music search engine where you can search for songs in plain English instead of exact keyword matching. The way it works is that the vector database looks at the meaning, so if you type songs about heartbreak, it finds tracks with that vibe, not just those with the word heartbreak in the title. We'll hook this engine up with 5 different vector databases to see which one really performs best. For data, we'll be using the musical sentiment dataset from Hugging Face, which contains tens of thousands of tracks annotated with moods and emotions, perfect for semantic search. If you want to follow along, run the benchmarks, and even spin up your own search UI on your own machine, I've included the GitHub repo in the description as well. So which are the databases that we're going to be testing today? Let's meet our contestants. First up is Qdrant. Built in Rust for speed and reliability, Qdrant is all about efficient vector search at scale. Second is Milvus. Backed by Zillis, and it was one of the earliest open source vector databases out there, so Milvus has become sort of like an industry standard. Third is Weaviate, an open source database written in Go. Weaviate sets itself apart with a strong focus on knowledge graphs and semantic enrichment. Fourth is Pinecone, and Pinecone is built specifically for production-grade vector search, with an emphasis on consistency and reliability on results. And fifth one is TopK. A newer player in the space, TopK emphasizes simplicity and blazing fast approximate nearest neighbor search. It's lightweight, developer-friendly, and aims to lower the barrier to entry for experimenting with vector search. So let's start by cloning our benchmarking Git repo. Again, the link is provided in the description so you can follow along. The first thing we need to do inside the repo is to create a Python virtual environment and install the required dependencies. Next, head over to the project's root directory and locate the sample environment file. Rename it to .env and fill in your preferred environment variables. You won't need an OpenAPI key unless you want to experiment with OpenAI's embeddings. We're not going to be using them here. The only required key is for TopK, since it's the only database we'll be running in the cloud. Next, we need to go to Kaggle and download the Muse musical sentiment dataset, which we will be using in our project. You will also find the link to it in the description. Go ahead and download the dataset and then head back to the project and drag the raw CSV data file inside the data folder. Make sure that the file is named muse.csv. As you can see, the file contains thousands and thousands of different music tracks alongside other valuable information about their genre and their related sentiment tags. Good stuff here. Next, we need to launch the Docker containers for Qdrant, Milvus, Weaviate, and Pinecone databases. TopK is the only exception because since they don't have a Docker container, we will be testing their databases through the cloud. So now that everything is set up and running, before we actually run our benchmark tests, we need to prepare our data for ingestion. With vector databases, if we want to use semantic search, we can't just drop in a CSV file and call it a day. We also need to create vectors that represent our data in high dimensional space. So our data first needs to be transformed into embeddings. An embedding is basically a numerical representation of the data that captures its meaning and context, turning text, audio, and images into vectors that the database can compare. To generate those embeddings, we use specialized models. Cloud providers like OpenAI and Cohere offer powerful embedding models themselves, but they do cost money per call and require an API connection. For this project, we'll keep it simple and use a Hugging Face embedding model to generate our data. The output will be saved in a Parquet format, which is efficient for large data sets and keeps the file size manageable. This embeddings file is what will actually feed into our vector databases for benchmarking. So go ahead and run this command, but it will take some time to generate the embeddings. But once that is done, we are now finally ready to run our benchmarks. To run the benchmark, we'll execute this command and pass in the names of all the 5 databases. If you're running it yourself, you can include or exclude whichever ones you like. And the test will also do a TopK sweep, which means we'll check how each database performs when we ask it to return the top 5, top 10, or top 50 nearest results. We'll repeat each step 5 times to smooth out randomness. That way we'll get the sense of the query speed and how well each database retrieves the right results under different loads. So let's go ahead and run the benchmarks. This will take significant time because for each vector database, we need to perform a full data ingestion before we can execute the TopK sweep tests. And once all the databases are ingested and the tests are run, the script will render out graphs of the results in the results folder. And we will look at them closer in just a moment, but first, I want to show you how you can use these 5 vector databases to make your own semantic search engine. Now that you have your Docker containers running and your data ingested, you can launch a dedicated UI interface using Weaviate, which is also included in this repo. And now we will go to local port 8000. And you'll see the search engine interface where you can query the databases directly. So we can now type in something like romantic love song, and instantly we see the top results from all 5 databases, each paired with a similarity score. This score represents how close the particular vector is to the semantic context of your query. You can even change the number of the results you want to display per database. And semantic search is so cool because I can write something like, "I'm feeling sad today," and the sentence transformer captures semantics and maps feeling sad into the same neighborhood as songs with sad descriptions and gives me back relevant results. All right, now let's get into the juicy stuff. Let's review the benchmarks and determine which vector database is truly the best. So first, let's look at ingestion time. We see here that Pinecone absolutely crushed it. It only took 6 seconds for Pinecone to ingest our data, while Qdrant was super fast too, only 14 seconds. We'll give TopK the benefit of the doubt here, because we were doing ingestion over the cloud for TopK, so that most likely slowed things down. So to be honest, Milvus did the poorest job here. Even running locally on a Docker container, it still took 103 seconds to ingest all our data. All right, let's move on to QPS, or queries per second. As we see here, Milvus and Weaviate absolutely dominate here, with having the fastest performance of all, and honestly, Qdrant and TopK did a pretty good job as well. Interestingly enough, Pinecone had the slowest QPS, so in terms of speed, Pinecone did the worst job, but don't jump to conclusions yet, because next we have to look at recall. And this one is really, really important. Recall is the measure of how many correct results the database actually finds. So imagine you're searching for your top 5 favorite songs in a giant music library. These are my top favorite, by the way. If the database finds all 5 of them, that's 100% recall. That is a perfect result. If it finds 4 out of 5, the recall will be 80%. So recall tells us how good the vector database is at not missing anything important. And here we want to specifically look at the recall from the top 50 results. So look at that. Pinecone got an absolute score of 1. Which in this case means 100%. This is insane. I actually had to double check my code to make sure it's not a bug, but no, indeed. Pinecone got 100% of the results right, even with 50 search results. So although Pinecone is slowest at queries per second, it always seems to retrieve the most accurate information. But look at that. Qdrant is not very far behind with a whopping 99% recall. Honestly, anything above 95 is considered top-notch quality for production search and retrieval augmented generation or RAG setups. And lastly, let's look at latency. We see that Weaviate, Milvus, and TopK are all consistently fast for all given K result metrics. And I have to give extra brownie points to TopK here because even though we were doing queries over the cloud, TopK still managed to have similar latency to all other databases who were running on local Docker containers. And look at that, interestingly enough, Qdrant actually becomes faster as you increase the number of results you ask for. This might sound counterintuitive, but it's likely because of how Qdrant batches its internal distance calculations. So performance actually scales better when you query for larger K values. Lastly, I just want to say Pinecone is noticeably slow. I mean, they do have that perfect recall, but as you can see, it comes with severe speed drawbacks. If we come back and look at our UI search interface, even here we can see that Pinecone queries are always a lot slower than all the other databases. So it seems like they definitely prioritize stability and accuracy over raw speed. So ultimately, here's my take. If you want raw speed, Milvus wins here with the lowest latency and high throughput, but ingestion is way much slower. If you want balanced performance and flexibility, Weaviate shines here with strong QPS and good recall. But there are some latency spikes, as you can see in this image. If you want stability and perfect accuracy, Pinecone gives consistent results at 100% recall, but at a cost of higher latency and low QPS. If you're exploring serverless or cloud-native trade-offs, TopK is promising because it has very low latency, and they are using serverless clusters and a node cache. This means throughput most likely gets better with time, and they have by far the easiest code setup to get up and running, but their recall is still lagging behind a bit. But if you ask me which one is the best vector database, I gotta give this one to Qdrant. Qdrant is solid, with fast ingestion, strong QPS at K50, and a near perfect recall. It is production ready, and honestly, Qdrant gave me the least headaches when I was setting up the code for this project. So congratulations Qdrant, you've definitely earned this title. So there you have it, 5 vector databases, 5 great options to choose from for your next project. Which vector database are you using for your own project? Let us know in the comments down below. And folks, if you like these types of technical breakdowns, let us know by smashing that like button below. Give us some suggestions on what to cover next. And of course, don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.